Hi everyone, I'm Rahul. Welcome to another video of the EKS series. In the previous video, we deployed our EKS cluster using AWS CloudFormation. Now that we know how to create an EKS cluster, in this video we'll focus on deploying the application and making it accessible to the outside world. In this video, we'll focus on the two main Kubernetes components, the Kubernetes load balancer and the Kubernetes Ingress. Before starting this video, if you haven't subscribed to the channel yet, do consider subscribing because it will motivate me to create more videos. So let's get started. So we'll start by creating an EKS cluster, and if you don't know how to create an EKS cluster, please go and watch the second video of the series. Alright, so our EKS cluster is created. Now let's connect to our cluster and deploy our application. But before that, let me explain you the architecture of our EKS cluster. So this is how our cluster looks like. We have two private subnets and two public subnets. Our EKS worker nodes are going to be running in these two private subnets, and then we have deployed our NAT gateway in the public subnet. And the reason being clear, because our EKS worker nodes are running in private subnet, they won't have access to the internet. To give them the access to the internet, we need a NAT gateway, so that whenever we run our pods, they can pull the container images from the container registry. And apart from that, we also have a dedicated subnet for our application and network load balancer. I'll explain this part later. Let's now connect to our cluster and deploy our application. Alright, so this is the EC2 instance where we have installed kubectl. Let's click on connect. Okay, so we have connected. I'll switch to the sudo user. And now, if you run the kubectl commands, you won't be able to connect to it. And the reason being clear. First of all, we need to add an entry for our EKS cluster, and to do that you need to run a command EKS update kubeconfig. Just copy this command from here, replace your cluster name here with your actual EKS cluster name, which in my case is prod, and replace the region with the region where your cluster is running. Okay, it says added new context. Now I'll just add an alias here. I'll run the command kubectl get pods, and you will see right now I don't have any pods running here. Okay, so now let's move to our GitHub repository and open this folder here, which is called 01 load balancer controller. First of all, we need to install the load balancer controller in our cluster, which will be responsible for creating the load balancers of type network load balancers and application load balancers whenever you create a service or ingress in the Kubernetes cluster. The load balancer controller will be using a role to provision the load balancers on your behalf, and for that we will need an IAM policy. So just copy this command, and now you will have a file here called impolicy.json. So this is the file that I'm talking about. Let's move to the next step, which is to create an IAM policy using the file which we downloaded here. So just copy this. Okay, it says an error occurred when calling the create policy operation because this user or the EC2 instance profile doesn't have permission to create an IAM role. So we'll give the necessary permissions here. Just open your instance and see the IAM role which is assigned to it. Just open this in a new tab And for the sake of this video, I'll give the administrator access, but in your case you can tailor down the permissions according to your requirements. So I'll click on attach policies, I'll select administrator access, and I'll click on add permissions. So the permissions are added. Now I'll again run that command. So it says a policy called AWS Load Balancer Controller IAM policy already exists, and it's because I already created it. But I'll for the demonstration purpose, I'll just delete that and I'll create it again. So I'll copy the policy name, I'll go to IAM, go to policies, I'll delete this policy, alright, the policy is deleted. Now I'll again run that command. Okay, so the policy is created again, and to check that you can just go here and click on refresh policies. Okay, here's the policy. Now let's move to the next part, which is to create a trust policy file with the following content called trustpolicy.json. So I'll just copy it. It's a crucial part, so please pay attention to this. I'll paste it here, and now here you need to paste your OIDC ARN. And where can you get that? Well, go to the IAM, go to identity providers, and here you will have an identity provider for your EKS cluster. Just open it, and here you need OIDC ARN. Just copy this ARN from here and paste it here. Here you need to put the provider name, so just copy this from here and paste it here. Okay, this part is done, and here you need to put the service account name, and the service account that we will be creating is called AWS Load Balancer Controller. So just copy it from here and paste it here. Okay, once this is done, just copy it again. Go to your kubectl server and create a file called trustpolicy.json. I'll just clear this part. Trustpolicy.json, and I'll paste it here. Okay, so this part is done. Now create a role using the CLI command. So just copy this command from here. Just rename the file to the file name that you have given, which in my case is trust_policy.json. Alright, so our role is created and it's called AWS Load Balancer Controller role. Let's go to the next part, which is to attach the IAM policy that we created. If you remember, we created this IAM policy here, and now we need to attach it to the role. So just copy it, and you need to paste your policy ARN here. So I'll again go to the policies, load balancer, and this is the policy that I'm talking about, and it was created just a few minutes ago. I'll copy the ARN and I'll paste it here. Copy this entire part and paste it in your kubectl server. Alright, so the policy is attached, and you can verify it from the IAM console. Just go to roles, search for load balancer controller role, and I think this is the one that I'm talking about. Yes, it was created 1 minute ago. Just click on it and you will see the policies are attached here. Alright, let's move to the next part. Now you need to create a service account using the following manifest. Just copy this part entirely, but before that you need to put your kube load balancer controller ARN here. So just copy it, open it in your notepad, and here you need to put the load balancer controller role ARN, which is this one here. Alright, just paste this ARN here, and now you're good to go. Just copy this entire part, go to your kubectl server, create a new file called serviceaccount.yaml and paste the entire part. Now you are ready to create the service account. Just write kubectl apply -f sa.yaml, and it says the service account AWS load balancer controller was created. Let's move to the next part, which is to install AWS load balancer controller using help. So first we'll run this command. By the way, Helm is already installed in your kubectl cluster if you have created it using the CloudFormation template which was given in the GitHub repository. It says EKS has been added to your repositories. Now let's move to the next part, which is to just update the local repositories. Alright, this part is done as well. Now I'll copy this entire command and I'll paste it here. Now we need to make a few modifications here. First of all, I need to give the cluster name, which in our case is prod. Create service account, keep it as false. Here you need to give the service account name, which is AWS load balancer controller, so no modifications are needed. But here you need to provide the VPC where your cluster is created. So just go to your cluster, go to networking and copy the VPC ID. Paste it here. Now you're good to go. Just copy this entire command and paste it here. Alright, it says the controller was successfully installed, and how can you verify that? Just run kubectl get pods in the kube system namespace, and you will see that there are 2 pods running of type AWS load balancer controller. So we're done with the first part, which was to install the AWS load balancer controller. Apart from that, you can also check the logs if you want. Just copy this command and paste it here. Just paste the command, and now you will see all the logs which are related to the AWS load balancer controller. Let's move to the next part. So we are done with this first part where we just install the AWS load balancer controller. Now we'll deploy an application and make it accessible to the outside world. So just open this part here. So in this part, what we are going to do is we are going to create a service of type load balancer. Whenever you create a service of type load balancer, AWS load balancer controller will spin up a network load balancer for you, and using that network load balancer, the audience or the public can access your application. So let's start by creating a deployment. I'll copy this entire script here. I'll clear the terminal. I'll create a file called deployment.yaml and I'll paste it here. By the way, the image that we are going to use is Nginx image. This part is done. Just run kubectl apply -f deployment.yaml. Okay, so the deployment is created, and you can verify that using kubectl get pods, and you will see there are 2 pods which are spinning up. Let's now continue and create a service to expose it. So now we are going to create a service of type load balancer, and if you see, the type is load balancer. And just now I said that whenever you create a service of type load balancer, the AWS load balancer will spin up a network load balancer for you. Apart from that, one thing that you need to focus here are the annotations. So if you see here, we have this annotation which says the AWS load balancer types would be external, which means the AWS network load balancer should be accessible to the outside world. So I'll just copy this part. I'll create a file called svc.yaml and I'll paste it here. Now I'll run this command again, kubectl apply service.yaml. So it says our service is created. Now you can check it using kubectl get service, and you will see that the load balancer has spin up, and here's the external IP of the load balancer, which is basically the DNS of the load balancer that you get when you create a network load balancer. And you can verify that from the console as well. Just go to EC2 console and check the load balancers which are present there. So you can see that the network load balancer is spinning up, and here's the DNS of the network load balancers. Let's try to access our application. It might not be accessible yet because the network load balancer is just spinning up, so we will have to wait a few minutes. Alright, so our network load balancer is created and the status is active now. I'll just copy this DNS name and see if we can access the application. Alright, as you can see, now we are able to access this Nginx page, which is the image which is used by our pods. Let's see what we can do next. So we successfully managed to create a network load balancer and a service using the service of type load balancer. Now let's move on to the next part, and now we'll create an Ingress resource and see how an Ingress creates an application load balancer for you and makes you access your cluster from the internet. Alright, before that, let me just delete the resource that we just created so that we won't have any confusion here. So if I do ls, I'll have a few files here. I'll just delete the ones which contains our resources like the deployment.yaml and the service.yaml. Alright, so my deployment and my services are deleted. Now we'll try to create an Ingress resource and see how AWS load balancer controller will spin up an application load balancer for you. So we are in this third directory called create ingress.md. We'll start by creating a service of type cluster IP. But before that, we also need a deployment, and where can we create the deployment from? We'll use the same deployment that we used for our previous example. So again, create a file called deployment.yaml, paste it here, run kubectl apply. Alright, so our deployment is created. Now we can continue to create our service. And here if you see that the service is of type cluster IP, because whenever you are using Ingress, the Ingress spins up an application load balancer which then forwards traffic to the services which are running inside the cluster. So I'll just copy this, create a new file called service.yaml, and I'll paste it here. I'll run kubectl apply. Okay, so my service is created. Let's verify it. Here's my service, and if you see now, we don't have any external IP because cluster IP services are only accessible inside the Kubernetes cluster. So let's continue to create an Ingress resource. Before that, let me just walk you through the configuration of the Ingress resource. So if you see here, the scheme is internet facing, which is just similar like the NLB, which means the load balancer isn't going to be private, rather it's going to be public. And here we have mentioned the service name to which it's supposed to route the traffic to, which in our case is Nginx service. So I'll just copy it, create a new file called ingress.yaml, and I'll paste it here. I'll just apply this file, Alright, so it says the ingress is created. Let's just verify it using kubectl get ingress. And here's the ingress resource that just got created. And apart from that, it also gave us the IP address or the DNS name of our application load balancer. So let's just go to the load balancers page and see if we have a new load balancer spinning up here. Okay, so a new load balancer is spinning up. It's in the provisioning state. Alright, so my application load balancer is created now and it's in active state. I'll just copy the DNS name and I'll open it in a new tab, and boom, we're able to access our Nginx application which is deployed in our Kubernetes cluster. So with this we came to an end of this video. Now what I'll do is I'll just go and delete my Kubernetes cluster from the CloudFormation template that I created or that I used to create this cluster. And deleting a cluster is very easy. All you have to do is just delete the CloudFormation stack. Click here and click on delete, and it will delete the CloudFormation template, which in turn will delete your EKS cluster. So I hope you enjoyed this video and learned something from it, and if you did, please share this video with other people and also subscribe to the channel if you haven't already done so. I'll see you in the next part. Till then, tata, bye bye.